This is section 4.4, Properties of Logarithms. And we're going to begin with applying the product, quotient, and power properties of logarithms. So we will be working with x, y, and b, all positive real numbers. And of course, b cannot be equal to 1, and that is the base of our logarithm. So let's take a look at the product property first. The log of a product is the sum of logs. How about the quotient property? The log of a quotient is the difference of logs. And finally, the power property, and here we have the log of x raised to a power, and that power now becomes a coefficient in front of the logarithm. So this power is this coefficient. Let's give this a try. We'll begin with number 1, and in number 1 we have the log of a product. So we were multiplying 2, x, and y. So this is equal to the log of 2 plus the log of x plus the log of y. And that is also a common logarithm, all base 10. Looking at number 2, we have the log base 2. So we have the log base 2 of 2 plus the log base 2 of x plus the log base 2 of y, also using our product property. But what do you notice here? The log base 2 of 2 is just equal to 1. And we come up with 1 plus the log base 2 of x plus the log base 2 of y. Now, taking a look at number 3, keep in mind we only have 2 factors, 3 and a plus b. So here we have the natural log of 3 plus the natural log of a plus b. We do not have a property of the log of a sum. We only have a property using the log of a product or a quotient. Okay, let's take a look at number 4. Here we're going to be using the quotient property, and I guess I should have pointed that out here. We use the product property. And now we have the log base 7 of z minus the log base 7 of 49. Now noticing that the log base 7 of 49 is asking 7 to what power is equal to 49, and of course that would be 2. Okay, looking at number 5, we have the log base 7 of a divided by 14. I can move these over here. And we have the log of a quotient, so now we have the difference of logs. Now, this is asking what power is 7 raised to come up with 14, and there is none. Well, it would not be a whole number. Okay, let's look at number 6. Again, we have the log of a quotient, so we have the log of 100 minus the log of x plus y. Now keep in mind that, and here we have 2 minus the log of x plus y. Okay, looking at number 7, now we're going to practice the power property. And as you can see, this is equal to 5 times the natural log of x. So this 5 will go into the front of the logarithm as a coefficient. Here we have 5 multiplied by the natural log of e. Keep in mind that the natural log is the log base e, and here we have the log base e of e, and that would be equal to 5 times 1, and we just have 5. Looking at number 9, let's rewrite this as the log of x raised to the 2/3 power. Now we can bring the 2/3 in the front of the logarithm as a coefficient. Okay, now we're going to use these properties to expand and also compress expressions of logarithms. So here we're going to be expanding using our properties. So as you can see here, we have the log of a quotient, and we also have the log of a product. So here we have a product, and here we have a quotient. Okay, so here we have the log base 3 of 5 plus the log base 3 of z, and now we have minus the log base 3 of w. Okay, we have to be careful because both 5 and d are in the denominator. So both of them will have a minus in front of the term. So the log base 7 of c. Now we have minus log base 7 of 5 and a minus log base 7 of d. This is one of the most common mistakes that I have seen. So we want to make sure we subtract any terms that came from the quotient. Okay, let's keep going. Here we have the log of a product. And now we can bring that 2 in front as a coefficient. Looking at number 13, we're going to rewrite this as the natural log of x to the 2/3 divided by w plus z. And that's equal to the log of x to the 2/3 minus the natural log of w plus z. And we can now bring that 2/3 in the front as a coefficient. Okay, let's get a little bit more complicated. The thing that you might want to do is notice first that this quotient is raised to the 1/2 power. And it makes it nice because now we can bring the 1/2 to the front of the term as a coefficient. And now we're going to have the log of a quotient. So, and this is all log base 2. So here we go. Now this 1/2 needs to be on the outside. And now we're going to have the log base 2 of 4 plus the log base 2 of x minus the log base 2 of y minus, let's see if we can do this. This 3 is a power. We can save a step. 3 log base 2 of z. Okay? And now what we can do is notice here that this is equal to 2. So we can go ahead and distribute the 1/2 to that, and we have 1 plus 1/2 log base 2 of x minus 1/2 log base 2 of y minus 3/2 log base 2 of z. And what I might do is change this step, and so we're not doing two things at once, and this would be log base 2 of z cubed. And then in that next step, bringing that 3 in front. Okay, let's look at number 15. And in number 15, we have the log of a quotient first. So that's equal to the log base 8 of 64 plus the log base 8 of x squared plus the log base 8 of y. Now let's subtract all of these terms. These are all negative terms. Okay, so now we'll take care of this 3 and this square, and then we also want to notice that this is equal to 2. So we have 2 plus 2 log base 8 of x plus log base 8 of y minus log base 8 of 3 minus log base 8 of z, and then we have minus 3 log base 8 of w. Lots of terms there. Okay, now let's go the other way. Now we're going to write this, these several logarithm terms as a single logarithm, and I actually sometimes call this compressed terms. So we are going to write this as a single logarithm with a coefficient of 1, and we will simplify as much as possible. So what do you notice? We have the difference of logs, and the difference of logs is the log of a quotient. And in number 17, we have a sum of logs. So here we have the log of a product. But before we do that, let's take care of this coefficient 4 and take y and raise it to the 4th power. And now we will have a sum of logs. So this would be the log base 2 of z y to the 4th. And if you like your variables written in alphabetical order, that's what that would be. Okay, let's look at number 18. Here you can see we have the sum of logs, and then we have the difference of logs. Let's take care of this 3 first. So we have the natural log of x cubed plus the natural log of x minus 2 minus the natural log of 5. So now we have the natural log, and we will put the x cubed and the x minus 2 in the numerator and the 5 in the denominator, since we had that minus sign. Okay. Looking at number 19, we need to distribute the 2 first. So we have 2 natural log of x minus 2 ln of x squared plus 2/3 ln of z to the 9th minus ln of z. Okay, so now we can see that we have here the sum. Well, let's go ahead and bring these coefficients. Natural log of x squared minus the natural log of x to the 4th plus the natural log of z. Now, 2/3 times 9 is equal to 6. So this is z to the 6th minus the natural log of z. So our terms that are positive are here, and then these are the terms that are negative. So now we can have the natural log of x squared z to the 6th divided by x to the 4th z. And we can simplify that. You can see that we have, let's see if I can make that a tad bit smaller. And we could reduce that, and we will have z to the 5th divided by x squared. Okay. Okay, let's try one last one, number 20. As you can see here, we have this negative in front of that first term. So we will have the opposite. Let's just keep that negative there as the term is negative and just move that 2 to the numerator, to the power, plus the log base 5 of x, plus the log base 5 of x squared minus 25. So now, as you can see, these are our positive terms, and this is our negative term. So we have the log base 5 of x multiplied by x squared minus 25, all divided by x plus 5 squared. I think I'll work to the right. So now we have the log base 5, and let's factor that numerator. We have x minus 5, x plus 5, all multiplied together, and with our x plus 5 multiplied by x plus 5. And now you can see that this is equal to the log base 5 of x multiplied by x minus 5 divided by x plus 5. Okay, looking at number 21, we are given these values. So as you can see, they give us that the log base b of 2 is this decimal, and the log base b of 3 is this decimal, 0.6826, and base b of 7. So we only have 2, 3, and 7 to work with. So let's see what we have. So we could say that the log base b of 21 is equal to the log base b of 7 times 3. That's the log of a product. And the log of a product is the sum of logs. And now we can use the values that were given to us, 1.2091 plus 0.6826, and that's equal to 1.8917. Okay, let's give this number 22 a try. And here we have the log base b of 9, and there's several ways we can do this, but how about the log base b of 3 squared? And that's equal to 2 times the log base b of 3, which would be 2 times 0.6826, and that would be approximately, and that would be equal to 1.3652. Okay. How about number 23? Here we're given the log of a quotient, so we have the log base b of 7 minus the log base b of 2, and we were actually given both of those values, and that would be equal to 0.7784. Okay, now we will conclude this section with the change of base formula. And what's really nice is that we can have any base we choose, no matter what base is given. Okay? So, A and B are positive real numbers, and A can't be equal to 1 and B can't be equal to 1. And the change of base rule says the log base b of x is equal to the log of any base you choose of x divided by the log of that same base of b. So in particular, we really like to go to the common logarithms or the natural logarithms. Because we have these on our calculator. So use the change of base formula and a calculator to approximate these logarithms to 4 decimal places. So let's give this a try. The log base 7 of 15 is equal to the log of 15 divided by the log of 7. So here we have used the common logarithm. You could have also chosen to use the natural logarithm, either way. So we're going to put this in our calculator in a moment. Let's try the natural logarithm base. And again, you can use either. The change of base rule says that this is equal to ln of 0.3 divided by ln of 5. And now we will approximate these in our calculator to conclude this section. Okay, so now we will find the log button of 15, and we're going to divide that, let's just start over. The log of 15 divided by the log of 7. And we come up with, I didn't do the log, the divided by. Come up with 1.3916. So we'll just use 3917. So approximately equal to 1.3917. Okay, let's now use the natural logarithm of 0.3 divided by the natural log of 5. And that is negative 0.7481. And that concludes this section.